Hello class, my name is Caleb Ives, and this is my project on solar-powered satellite internet in the fishing village of Cao Van, Vietnam. So just a little bit of information on the area that I chose. The fishing villages of Cao Van are close to the Vietnamese city of Hanoi, which is in the northern region of Vietnam. My justification for the project is that many times these fishing villages go without access to clean or consistent power. Many of them are very low income. They typically use diesel generators or even, as the picture shows, these fabricated wind bucket turbines. And a project like this would help reduce pollutants because the water there near these villages is regularly contaminated and they've had fish die-offs at times. So my purpose for providing internet to these people is that it boosts an entrepreneur's success. That's been proven many times. It also provides these entrepreneurs, basically fishermen, with access to larger markets where they can sell their goods, and they can improve their relationships with local stores and restaurants. It can also reduce overcatching. For instance, they might catch too many fish and then not be able to sell that. Well, this will give them better market awareness. It also helps enhance communication, which improves safety amongst fishermen, and additional outcomes might be that it reduces overfishing of the area. They will have better awareness of how many fish they their their comrades have been catching, and in addition to that, they have access to social media, which is also helpful. Solar information. Hanoi is unfortunately in the more green region of this insolation chart. I'd like for it to have been a little bit higher, but unfortunately we've got what we've got. Insolation is about at 2.4, and that's in the month of January, and it gets up to about almost 5 in the month of June, but we're going to size this for the worst month, so we're going to go with 2.4. The sun path, as you can see from the chart up here, does vary rather significantly throughout the year, and so we're just going to go with our rule of thumb and use latitude plus 20 for our tilt angle. So the latitude in Vietnam, or in Hanoi specifically, is about 21 degrees. So we're going to tilt those solar panels at 41 degrees. So the plan of action would be to find potential candidates based on several factors. First of all, the structural integrity of their floating home. We don't want anything collapsing or tipping over or something like that. The legitimacy of their business, connection with their community, and also technical abilities in case they ever need to access the system or repair it or something of that sort. So our load items are going to be these MacBook Pros or any equivalent laptop. We're going to have 2 of those. Cell phone charging stations, an Exedi satellite internet system, or the equivalent for the area. It'll need a modem or modem slash Wi-Fi router, and obviously the satellite uplink, 2 11-watt fluorescent lamps, and a small office printer. The loading characteristics here, we can see that our amp hours per day are about 40.49, which is not that much, and our total kilowatt hours per day is about 1.5. So this is a very small system. The PV modules that I've chosen are these Neo Solar Power 350 watt panels. They are about 50 pounds each, $230, and we're going to need 2 of them in series since they have a short circuit current of 9.4 amps. They also provide 40 6.89 volts of electricity. The batteries I chose are these UPG U8 8D AGM batteries, absorbent glass mat. They have a voltage of 12 volts, 250 amp hour capacity. They'll last for 1200 cycles, and we're going to need 2 of those in parallel. The inverter that I chose is the Magnum Energy 1212 AE inverter. It outputs a modified sine wave at 1200 watts. It takes an input voltage of 12, and even though we're not going to have any surge currents from these types of loads, it can handle up to 42 amps in a millisecond, and its efficiency is 95%. The charge controller is the Morningstar SunSaver maximum power point tracking controller. It can take a maximum input of 60 volts and will charge our 12 volt batteries effectively. I also chose this controller and the inverter because they are marine rated and can take vibration and also the moisture that's normal in that area. So here's our system. We've got our solar modules, charge controller, batteries, inverter. The solar panels will be mounted in parallel. There's 2 of them. The batteries are also going to be in parallel. We've got 1 charge controller, 1 inverter, and the inverter is going to be powering every load that's on the system. So our pricing comes out to about $2,474 just for the PV system alone. That's not including travel expenses or shipping expenses, which will increase this significantly. And the load items like the laptop and printer add an additional $3,300, so the grand total is around $5,800. That's the end of my presentation. Thank you for listening, and have a nice day.